Welcome to the show, Shreyasha ji.
Thank you for the invitation. I'm excited.
Okay, thank you very much for coming here and making your time for this podcast. So, to the audience, could you please introduce yourself?
So I'm Shreyasha Paudel. By training, I'm an engineer. By work, I call myself little bit of khichadi.
Okay.
मेरो background चाहिँ general engineering, robotics. So since then, I've been working in AI for a long time. I used to work for a self-driving car company. We'll talk about that more, I'm sure. And then towards the end of my work there, I worked on basically quantifying and measuring the validation and safety and uncertainty when AI fails.
Mm-hmm.
And then after that, I moved back to Nepal about a year ago. And then I've been working in basically responsible AI in the context of Nepal, but also in the context of other developing countries, looking at what is the gap between how we think about AI from a technical perspective and the reality on the ground, right? There's a lot of social factors, but also a lot of political, legal factors that affect the data we can get, the applications we can use, and so what's the gap there and how can we bridge that gap so that we can actually get a product that works.
Okay, you have a very interesting domain that you have picked up. So before going to AI, ML, like we'll talk about that later on. Obviously, it would be the highlight point of this podcast. So I just wanted to understand, like when you mentioned about general engineering that you studied in the USA, like what exactly is general engineering and how it is different from like whatever the engineering that we are studying in Nepal?
So I started engineering in Nepal. I studied for a year in Pulchok. I was doing electronics. And then by the end of that year, I realized that I really disliked engineering.
Okay.
Surprise. In hindsight, it's because the way it was taught, it's very theory-centric. You start with all these chapters and equations and exams, and you have no connection with like why you are learning it, right? And then also the professors didn't really engage. Even when they're teaching the theory, it's just like go on the board, write stuff. And then there's few people in the front row who ask questions, but the rest of the people are just disconnected. And so I was like, okay, I hate engineering. I'd already done physics in my +2 ISC, so I was like, I can be a doctor. I don't want to be an engineer, and I had no idea what I wanted to be. Right, Nepali, good student, those are the only two options you have. And so I decided to apply to US. I applied to a bunch of schools, and then I ended up in Harvey College where I got a really good scholarship. So there was no like plan of what I wanted to do in life. Luckily, I ended up in a school which was a liberal arts school with a focus in STEM. What that meant was like you got a STEM degree, but also you had to do a lot of classes which was outside of STEM, looking at social sciences, history, art, music, psychology, economics. You got to pick, but you had to do non-STEM courses. And then within STEM, the engineering itself was general engineering. And what that meant is the first 2 years, you took required physics, chemistry, math, then required introductory classes in chemical engineering, electrical engineering, computer science, genetics, mechanical engineering. And then after that, you chose electives in a way that you could decide your specialization based on interest. And so my engineering is a lot of focus with design and systems, thinking about like engineering systems as a whole, with like a focus on robotics and designing systems for robotics applications.
So and that's why like you ended up selecting that particular field, and like pachi you did masters in aeronautical. Like how did you ended up in aeronautical?
It's serendipity for the most part. I like to say it as a really interesting story because my college had just hired a professor, and then I think it was his first day or the first week, and then he ran this like knowledge sharing session, right, with pizzas. I had just gotten out of a lab, and then me and my friend were really hungry. We saw like pizzas on the table, so we walked into that room, and that professor used to work on robotics. And so he used to do build these robots to go explore places where humans can't go to. So we used to do experiment in like caves And then another was like build robots and work with biologists to explore like underwater and track animals. And then the application sounded really interesting. At that point, I didn't even know if I wanted to do engineering. I was thinking about physics or math. But the application sounded really interesting. There was good food. And then the whole point of the session was because he was a new professor, he wanted to hire some students to work with him.
Mm-hmm.
So it's like, let's apply. What's the worst that can happen? And then I ended up working in the lab for almost 3 years.
Oh, that's interesting. So you started as studying in like Pulsuk AFEMA, like it's something that's very renowned, Nepal IIT is the level kasa. And then you ended up studying in the US in the masters, and as well as and then you ended up working in a company, Ford, to expertise in your AI and ML like any. So you have covered a lot of domains in like in your undergrad and graduation co entire period, ma. So like at the end, like what made you inclined towards AI ML in your like further career?
Again, I think it's serendipity, right? A lot of my decisions have happened in a way that I've chosen what I don't want to do. Right, like Pulchok.
Okay.
And not to say Pulchok is a bad campus or bad institution. It's one of the best institutions. I know many Pulchok graduates who've done amazing things. For me, at that time when I was 18, it wasn't the right choice. Similarly, with like robotics, it was basically food, but then I really enjoyed the work. My advisor was a really good mentor, and then we had really good synergy, and we ended up working. And then with AI, similar stuff. Because I was working on robotics, and then I graduated, finished my bachelor's in 2014, started my master's in 2015, which was when a lot of this self-driving car hype had started, right? So it was like there was a lot of funding, a lot of interest, a lot of really exciting research happening. And so it was a little bit of timing, and I was interested in the use of robots. And so a lot of these research areas aligned with my application interest, and so I ended up there.
Yeah, nice. So let's get into the main our interesting portion of this conversation, like that's AI and ML. So like there's a lot of confusion going around like AI and ML, what exactly it is, and everyone says they are an AI ML engineer, but like many people say that, and they like ended up having a very wrong concept of what AI and ML is, right? So to on a very base start level, like what would you define like ML first, and then like what do you define AI?
I'm gonna switch the order. I'll start with AI first and then go into ML. So AI, right? A for artificial and I for intelligence. त्यो दुईटै कुरा चाहिँ I'm gonna switch to Nepali a little bit. Are very philosophical topics, right? I mean, you can define it technically, or you can come at it from many different perspectives. But the definition आफैमा नै complicated or contested. So I don't think there is like, this is the true definition that like everybody should agree. Because artificial by itself means man-made, but then where is that line? I don't know. And then intelligence, what is intelligence, right? So the way I define it is it's some kind of man-made system. It could be computer mabako code, it could be a mechanical device, it could be something else, right? That is, there is a human contribution to it, and then something, by intelligence I use like decision-making ability, which makes some kind of decision by itself. So from self-driving car perspective, a traffic light, right, even with just a timer, could be an AI because it's artificial, and then when the light turns red, light turns green, light turns yellow is like some kind of decision being made at each point, right? So that's an AI system. Now you can make it slightly more sophisticated and make it change those colors based on the traffic pattern.
Yeah.
And then it becomes like, then like everybody can agree it's an AI.
Yeah.
So that's sort of where the boundary is, like where you draw the line of like decision-making system. The other way to think about it, like from an engineering perspective, is something that takes inputs, right? Some signals as inputs, and then gives an output that is a decision. And that decision requires some sort of cognitive function.
Okay. So does that mean like every machine in this world is AI capable or AI enabled or AI machine भन्दा मिल्छ?
In a way मिल्छ, in a way मिल्दैन. So like a clock, I wouldn't call it an AI, but an alarm clock, you can, if you stress the definition, it could be an AI.
Okay, so in that case त यसमा चाहिँ मेरो पनि त्यो अलिकति I have a different perspective on that हैन, because the alarm clock is actually programmed to do that. हैन, there is a conditions हुन्छ नि जुन चाहिँ pre-made conditions यस्तो भन्छ यस्तो गर्नुपर्छ भनेर अलरेडी डिफाइन गरेको कन्डिसन्सहरू छ हैन, त्यसले गर्दाखेरि इट मेक्स एन डिसिजन एन्ड देन लाइक अलार्म बज्ला अर वाट एभर इट इज हैन. तर isn't AI is more into like making decisions on their own and like based on the inputs and whatever it comes up on it?
So that is the philosophical part, right? Where do you draw the line? AI को intro course मा चाहिँ त्यस्तो सिस्टमलाई rule based AI system भन्छ के. And there's a lot of like really sophisticated system, like a lot of missile control system aerospace or like rocket launching system which are completely rule based because you want certainty, right? तर त्यो rules चाहिँ alarm को case मा 8 बज्यो ट्रिङ गर भन्ने मात्रै हुन्छ, तर त्यो रुल्सहरू क्यान बी मोर कम्प्लिकेटेड, राइट? बट इट्स जस्ट इफ देन स्टेटमेन्ट, नेस्टेड इफ देन स्टेटमेन्ट फर लाइक अ लट अफ स्टेटमेन्ट्स. सो दोज आर still AI systems. AI courses you have to learn about them. They're called rule-based AI systems. But then as the systems get more sophisticated, it's hard to think about like really simple system is like, hey, you open the AI only one. But for an example, calculator, right? Nobody thinks of calculator as a computer anymore. But I'm 6-7 ma computing ka history part that we always started with like sliding rule, then calculator. Then balla computers aako hunta ani yo pani testay system ho ke like any human decisions, like when you go really at the end, then any decision making system can be an AI. But as like the decisions become more and more complicated, we start like separating as humans where like the boundary ends and starts.
So there is no real definition of like what exactly this is or what exactly this is not. So it's,
and then like for a non-technical person, inside that black box ke bhairako cha bhanna garo huncha ni ta. For me, like when I think of self-driving cars, right, there's like 5-6 blocks. Some of them are rule based, some of them are like equation based, some of them have like these really complex machine learning systems, and then because I've worked on it for so many years, I know what the differences are. But for a technical system, it's just a self-driving car. It's a really complicated thing. Manselai sikna mahina लाग्छ. The car is driving itself. It's AI.
Okay. So it's about perception of a person. Okay, and interesting. So what is ML in that case this way?
Oh, so defining machine learning, I think, is a lot easier. Because it's a system where, again, machine and learning, right? So the machine learns itself. In that case, rule-based system actually defined गरिसकेपछि, to change it, we have to change it, right? In machine learning system, you give it some data, and then based on the data, the machine learns the rule themselves. That's machine learning.
Okay, what could be a very basic example of that?
Very basic example is like Facebook of photo tagging feature, right? We've all seen, and click garyo bhane it gives you recommendations on like kasko face ho. And the way Facebook treats it is billions and billions of मान्छे र नाम, right? अनुहार र नामको फोटो दिएर उनीहरूको algorithm लाई पठाइरहेको छ. And then over time, the computer learns like facial features, right? नाकको shape, ओठको shape, आँखाको shape probably, complexion, hairstyle probably, to associate that face with that name or that profile.
Okay. So यसमा मेरो like मेरो पनि आफ्नै पर्सनल इन्ट्रेस्ट र लाइक मलाई पनि आफूलाई आइराख्ने क्वेसन चाहिँ के भन्दाखेरि लाइक एमएल इनेबल गर्नुको लागि डु यु रिक्वायर लाइक रियल टाइम कम्प्युटेसन अल द टाइम? किनकि हामीले आजकल हेरिरहेको छ कि लाइक डिभाइसेस आर जस्तै फर इक्जाम्पल एप्पलले के भन्छ भन्दाखेरि अल द एमएल प्रोसेसिङ इज डन इन द मोबाइल इट्सेल्फ, देयर इज नो डाटा गोइङ टु द क्लाउड एन्ड ट्रान्सफर भइरहेको छैन भन्छ होइन. लाइक हाउ डज द्याट वर्क? लाइक डज इट रियली रियल टाइम कम्प्युटेसनल हो कि कसरी काम गर्छ त्यसले चाहिँ?
सो मसिन लर्निङ एल्गोरिदम कुनैको पनि दुईवटा स्टेप्स हुन्छ कि एउटा चाहिँ अघि मैले भनेको ट्रेनिङ स्टेप राइट ट्रेनिङ स्टेपमा चाहिँ द एल्गोरिदम डजन्ट नो वाट इट इज डुइङ जिरोबाट स्टार्ट गरेको पनि हुनसक्छ हल्का बेस लेभल हुनसक्छ होइन थिङ्क अबाउट लाइक 1-2 वर्षको बच्चा जो भर्खर बोल्न सिक्दैछ अनि यु पोइन्ट द काउ कुकुर एन्ड बी लाइक भाउ भाउ एन्ड देन ओभर लाइक अ फ्यु मन्थ्स त्यो बच्चाले पछि आफै त्यो कुकुर पोइन्ट गरेर भाउ भाउ भन्न सिक्छ होइन सो द्याट इज द ट्रेनिङ स्टेप वेयर यु गिभ lots of data, lots of examples, and then during training the algorithm learns to recognize patterns. त्यसको लागि we need a lot of computation. And then training takes like, depending on what you're training, hours, days, sometimes months. But त्यसपछि जुन युज हुन्छ नि इन्फ्रेन्स भन्छ होइन त्यसमा चाहिँ यु जस्ट गिभ वान डेटा पोइन्ट एन्ड देन बेस्ड अन द ट्रेनिङ इट लाइक figures out the pattern and gives you one output. That is not very computationally intensive. So Apple ले भन्ने फोनमै प्रोसेस भइरहेको छ भने चाहिँ त्यो इन्फ्रेन्स स्टेज हो and then between training and inference when you deploy it in the machine you also do a lot of optimizations to make that compute even like less compute intensive.
Okay, so it will still require real real-time computation to make that decision or maybe out to the knuckle.
Yeah, it requires real-time computation, but that is a lot less compute intensive. So
than when it's doing the training stuff.
Yeah.
Okay, so two stages we divide गर्दाखेरि चाहिँ training र implementation.
Inference. Inference.
Okay, training and inference phase मा चाहिँ so training might require a very heavy real computational. The inference मा चाहिँ it might not require. Okay. And like how is AI and ML connected? I like it comes up hand in hand and जहिले पनि AI भन्दाखेरि ML सँगै टाँसेरै आउँछ and it's like जिग्री दोष जस्तो भएको छ दुवैजना हुन्छ like how they are actually connected then?
So AI as a concept, as a technology, as a research field is not new. From like when we had calculators, right? Not even computers, we've always had this idea of like a machine that replicates humans. And AI भनेको चाहिँ different ways of trying to do that हो न so it started like from the 30s, 20s. There was a translation machine built before there were computers. But 1970, 1980 मा चाहिँ AI winter भन्छ होइन so a lot of technology techniques that we tried didn't really work well and then people had given up. And then late 90s मा चाहिँ यो machine learning को जुन अहिलेको technique छ had a renaissance. And so suddenly a lot of things that we couldn't do were possible. त्यसमा दुई तीनटा कुरा छ one was like the compute had become a lot more powerful so we could do a lot more sophisticated math. Second there's this technique called backpropagation where we could now त्यो अघि मैले जुन pattern matching को कुरा भने नि you do a forward pass where you try to randomly guess the patterns and then you do a backward pass and then try to optimize it to the right answer. So the technique developed भयो होइन so over time what happened was like with more data we could actually learn very complicated patterns without us humans knowing what the patterns are. Like when I look at a picture and recognize a dog or a cat, I don't know what I'm looking at, right? त्यो त मसँग वर्षौंको experience, probably also evolutions, right? Generations को experience is there and then कान मात्रै हेर्यो भने पनि होइन थुतुनो मात्रै हेर्यो भने पनि होइन फर मात्रै हेरेर पनि होइन I don't know like if somebody asks me what the difference between a dog and a cat is it's really hard to explain. But give me a picture of a dog and a cat and I'll recognize it every single time. And so त्यस्तो codify गर्न गाह्रो like things we knew was right but we couldn't explain like how. So with data the computer started to learn itself. And then suddenly a lot more avenues for applications opened up. And that was through machine learning. So a lot of AI applications that are commercialized are along those veins, right? Image recognition, image captioning, language translation, language generation. And so like most things that were difficult and then suddenly become possible due to machine learning. So AI and ML सँगै बनिन्छ but ML is a small subset of AI.
Okay, interesting. So with that, like when you started working on Ford, Like, what was your role like as an intern where you, when you worked there?
So as an intern, I was working on basically an evaluation system. So self-driving car ma अहिले पनि, right? One of the biggest problem is 3D recognition, because like images that we use with cameras, they have a 2D thing, and then because the depth axis depends on the focal axis, there is an inherent, like, it's impossible, right? Without two cameras, you cannot figure out the depth. It's physically impossible. And even with two cameras, there's a lot of like noise factors which affect it. And then the further the object is, it's hard to recognize the depth. And so a lot of cars use laser scanners, LiDAR sensors to do that 3D object detection. But lasers are expensive. LiDAR scanners are extremely expensive. Google Karma used a laser scanner when I was starting on this project costed, I think, about $200,000-300,000 one device.
Okay, LiDAR on laser on
LiDAR. त्यो टाउकोमा यता ठुलो छ नि. अहिले त they manufacture itself, that the cost has come a little bit down, but at that time.
When was that?
2016.
16. Because all the even every smartphone, like iPhone, they have LiDAR scanner.
Yeah, like, so laser scanner by itself, the त्यो हामीले प्रोजेक्टरमा युज गर्ने laser pointer पनि it's a laser scanner हैन. तर कारमा युज हुने चाहिँ it's a rotating object, and then you have multiple beams to get the resolution you need.
So it's not like one एउटा direction मात्र हैन, it's like in multiple directions.
It's like 360 degree with like, I think they used to have 1 centimeter resolution. Which is why it was expensive. And so my project was, there were other startups trying to build a cheaper laser scanner. And so my project was to basically develop algorithms to compare them and then see if we can get the cheaper scanner
working
comparable to the more expensive one with like software.
That's nice. So how did that go?
That was interesting because we're working closely with a startup, right? So the laser scanner itself nay finished product thena. They were trying different patterns to scan, because one of the ways you can counter resolution is like if you what you're doing is scan really fast. And so instead of like one beam scanning just one point, if you do it really fast and use the same beam by like moving the parts to scan multiple points, then एउटै laserले धेरैवटा लेजरको काम गर्यो नि त, and that's one way to bring the cost down. But then त्यसलाई descramble गर्नु is the softwareको part, right? Now if you had a one beam, then decoding it is easy, but if that beam goes in a Z pattern, then you have to decode it. And so there's a timing issue, like now decoding takes a lot longer, which is time sensitive. So we were working with the lasers company to figure out like what scanning pattern would be best, how many beams is like mandatory, and what we can subscribe. So there's no like, oh, we succeeded. It was more like it was an iterative process. And then because the company itself was a startup, they had their own funding struggles, employee struggles, etc., etc. So it was an interesting project. And then I think what we discovered was they had an 8-beam laser, 16-beam laser, and a 32-beam laser. And then the expensive one I was talking about was a 64-beam laser. And so we were like, okay, 8-beam, not possible at this time. 16, we could do it, but only for like low-speed applications. And then we at least required 32 for high-speed applications. I think that was like my conclusion. Given the state of technology at the time.
So for someone who doesn't understand how self-driving car works, like we know it. Let's not say self-driving, because you mentioned none of the car in this world is self-driving. So like let's say autonomous vehicles, like what would define an autonomous vehicle? Like जुन चाहिँ marketing hype बाहेक निस्किएर जति पनि यो real world applications छ नि, like what exactly that is and how does that actually work in real world?
So scientifically, Americaको NHTSA, National Highway Transport Safety Board, ले चाहिँ 5 levels of self-driving car भनेर define गरेको छ हैन. Level 0 is no automation. So think manual car. Even अहिलेको manual कारहरू level 0 हुँदैन तर remember त्यो Maruti Suzuki where even the window was like हातले घुमाउनु पर्ने ऐना हातले घुमाउनु पर्ने like no automation, everything by human. That is level 0. Level 1 is either longitudinal control or lateral control is done. Only one of them is done. Okay? So steering ma assistance छ भने all of the brake and accelerator is humans. Responsibility or usually cruise control भन्ने feature हुन्छ हैन, which is it maintains the distance but only in a particular lane. So that is level 1 usually, where the algorithm controls the accelerator and brake, but steering, perception, like figuring out what's around is all your responsibility. Level 2 is what is in the market अहिले, which is both steering and brakes, right? Both lateral and longitudinal controls चाहिँ humanले गर्न सक्छ, but then perception is the responsibility of human. So there are sensors, radar छ, cameras छ, they detect the objects but they don't know, or it's not 100% accurate. It's not the responsibility of the car to detect it. The final decision is made by humans, but control चाहिँ गाडीले mostly गर्छ. Then level 3 आउँछ, which is sort of this gray area, which is basically to make it continuous. Okay. So level 4 is when the car can drive itself. When we think of self-driving car, we think of level 4 or level 5 हैन. त्यो चाहिँ गाडीले मान्छे मस्त बस्दाखेरि चलाउन सक्छ हैन,
without being एकदमै active or
human is not responsible. Level 4 भनेको चाहिँ you can just take a nap, read a book, the car will drive. Difference between level 4 and level 5 say level 5 is everywhere, level 4 is well defined conditions ma. So you say the car will drive itself in a city road, highway, then it will drive itself on a highway, pani paros, asina paros, jesuki hoस्. Or you can say that the car will drive itself on a sunny day, and then it will have to drive on a sunny day, highway ma, city ma, bike hoस्, jesuki hoस् हैन. Accident hoस्, the car needs to be able to handle it. So boundary conditions well defined भएपछि within that boundary condition you can take a nap and the car can drive itself भनेको level 4 हो. Level 3 भनेको चाहिँ त्यही level 2 र level 4 लाई connect गर्ने intermediate step हो के. It's again AI को definition, it's not really well defined, but between like human being fully responsible and human being completely out of the loop, there's a big gap, right? And so any feature that's like in between, Tesla ko autopilot for most part, right, is level 3. But when we think of it from a legal point of view, level 3 is really hard to define and enforce. So legal basis ma चाहिँ level 2 र level 4 मात्र exist गर्छ.
So आजको दिनमा like if you define Tesla को legal way, so they are still on level 2. So but how they all market like it's हुन्छ नि, it's all self-driving, you don't have to worry about anything or everything हैन. किनकि I used to watch a lot of videos that like how Tesla used to autopilot and everything, अनि एकदमै well defined condition मात्र राम्रोसँग चल्छ नि त. किनकि like नेपालमा त आछै छैन हैन, for the roads and for the traffic condition and everything possible छैन. US मा पनि एकदमै strict well defined situation मात्र राम्रोसँग काम गर्ने रहेछ हैन. तर what are like challenges that comes up in autonomous vehicles, like in a real world, like not from a technical perspective, तर के चाहिँ आउन from like road may to move that vehicle?
Corner cases. One of them is basically if you've ever driven, especially if you've driven in Nepal, but जहाँ drive गरे पनि हैन, if you've ever driven, you can't really predict what's gonna happen, right? Weather is one big thing. Like जति नै राम्रो sensor भए पनि suddenly पानी पर्यो भने cameras are not gonna work. I have driven in a road where I could only see like 2 meter अगाडि हैन, and then you go really slow and then you hope that other people can like behave, right? Or अगाडिको गाडी बिग्रियो, झाप्पै रोक्यो, what can you do? Now, so there's like a lot of these unpredictable things, that it's a mechanical system. Everything in the road is a mechanical system. Something will fail. And then you can't really predict what will fail when there's lots and lots and lots of failure modes. So that's one. Second, compute ko kura ho, हैन. Right now, to make a car fully self-driving, you need a lot of compute.
Mhm.
Even inference scale lagi pani, because you're making a lot of like really safety critical decisions in a really fast time, you need a lot of compute. And what that means is त्यो compute ले त फेरि petrol लिने हो नि त. And so mileage reduces significantly, which is fine when we are using experimental vehicle for like testing. But if you are used to like 20 miles per gallon ko gadi chalairasa, and now somebody sells you 5 miles per gallon ko gadi cha, but it drives itself, it's not a very viable product. You know? So mileage and the cost between compute and mileage is one big risk. One way to counter that is with cloud compute. Right, then it doesn't have to use the fuel, but then there's a cybersecurity risk, data bandwidth risk, right? Like internet goyo, what do you do? And so it's just a very systems level ma sochdakheri, there's lots of moving parts and each of them can fail, and the way to do it in a way that there is contingency plan is challenging.
So your self-driving there is a lot of complexity when it comes to like if you are trying to reach level 4, level 5 in that case this way. Okay, so but when you talk about like edge ma compute garna garo huncha bhane we can leverage cloud in that case. Is that where 5G comes up?
That's where people are thinking 5G comes up.
But
I mean, I'm not sure. I mean, it's also been about a year where I don't know what the state of the industry is. So I look at the outdated information.
Okay.
But the problem with, again, 5G or any cloud compute is I don't think the cybersecurity infrastructure is well ascertained. And then with any network, like dealing with the latency issues, right, and bandwidth issues. And अहिले phone ko kurama nai, like you have 5 phones in the house and suddenly you have 15, there's so many issues, like traffic pan testay ho ni ta, you can't really predict how many cars will be on the road at any moment. And so dealing with that fluctuating data needs, bandwidth needs is again going to be difficult.
Yeah, so 5G ko conversation चाहिँ कहाँ आउँछ यो यसमा भन्दाखेरि चाहिँ I've been following 5G as well, अनि त्यसमा चाहिँ it's more about अलिक सिस्टम आर मोर 4G related हैन. So 4G मा चाहिँ के भइरहेछ भन्दाखेरि चाहिँ you can travel longer distances, तर त्यो अनुसारको bandwidth को issues र latency पनि high हुँदै गइरहेको छ हैन. नेपालमा 4G if you try, like the max speed that you'll get is like 30 Mbps 40 Mbps हैन. तर बाहिर it's like 100 and something like that. तर 5G मा चाहिँ what you can have is almost you can have a gigabits of I might be wrong, but I think it's almost a gigabit. So gigabit ko bandwidth with a very low latency with the server भन्ने छ हैन. So that's where there is a narrative saying कि self-driving carsहरूलाई चाहिँ computational self-driving नै गर्न गाह्रो हुन्छ भने चाहिँ they can use the power of cloud, अनि we using 5G as a very high bandwidth and low latency system. तर it's something that's still on implement भइसकेको छैन, it's still going on. Like अस्ति 5G implement गर्दाखेरि many airlines had to shut down their operation because it messed up with the radio communication सबै कुराहरु छ. तर this is what like they are thinking like it would solve the problem.
5G को अर्को advantage is it's a better, it gives you more resolution on where the signal is coming from. So गाडी कहाँ आइरहेछ भन्ने कुरा जुन हामीले GPS र cell tower बाट localize गर्छौं, we get a better resolution. Again, on so cloud compute गर्दा त्यो बाट पनि सजिलो हुन्छ, because at the end of the day you are driving on the road and you know exactly where on the road you are, right? And once you send the data out, by the time the data comes in, you'll be driving a little bit more.
Okay.
But at the same time, this is a debate between also like the server then कति frequency मा राख्ने, what's the infrastructural cost, density ka kura auncha, right? How does it behave in urban centers where there's lots of people and lots of confounding signals versus rural areas where you probably do want like more distance go bandwidth, right? Like it's not possible to put really close servers where there's no people.
Yeah, true. So त्यसमा पनि अर्को डिसिजन सिस्टम पनि आउँछ होला, where like के चाहिँ क्लाउडमा प्रोसेस गर्ने र के चाहिँ एजमा प्रोसेस गर्ने भनेर. like emergency braking, obviously cloud is not the best plat, and if it has to stop, it has to stop, and you cannot wait for decision made by others. So probably अब के चाहिँ गर्ने भन्ने एउटा त्यो पनि कन्फ्युजन चाहिँ हुन्छ होला. So it's a very complicated topic. अब कुरा गर्दै जाँदाखेरि चाहिँ हैन feels like there is a lot of complication going around on this. So तर when do you think like we'll be able to reach the level where like okay we have a self-driving car that can we can just sit in the back seat and then just relax about that?
So even when I was in 2016-17, when I was like quite optimistic about the whole research projects, I called myself a self-driving car skeptic. One of the reasons I left my job is because I don't believe in self-driving cars.
Okay.
But I think like दुईटा कुरा छ. एउटा चाहिँ I think this focus on self-driving cars itself is misguided जस्तो लाग्छ मलाई, because we have something where we can relax in the back seat. They're called trains. They're called trains. They're electric. They're good for the environment. They like work for way more people, and they can be much faster than cars, less gridlock, etc., etc. That infrastructural investment is going way towards self-driving cars than trains. So which is again, it's more a social and political issue. Second, like thinking about cars today, right? Even मैले अघि नेपालको मारुति सुजुकीको एक्जाम्पल दिएँ, जहाँ पनि पुगेको छ के. I've seen it like गाडी बाटै नभएको कालीगण्डीको बगरमा पनि हिँडिरहेको छ होइन. अनि वान वे ट्राफिकमा ऐना बेन्ड गरेर ड्राइभरहरूले चलाइरहेको हुन्छ. नेपालको त्यो रोडै नभएको ठाउँमा एकदम स्मुथ हाइवेमा पनि चलिरहेको हुन्छ. पानीमा असिनामा राति दिउँसो सबै चलिरहेको हुन्छ. I don't think like as an engineering system, as somebody who's worked in like algorithms trying to define them, those are all very, very different technical problems. Like a car that can drive off-road requires very different sensor set than a car that goes like
on highway or
200 kph on a highway. And so like I think over time what will happen is the systems will be optimized for use cases. So you can buy a car that goes and relax in the back seat and then drive it both to like off-road Narako Tupoma, also like to your office, also like on a highway road trip. But I think what will happen is like there will be a set of systems like logistics lagi, right? Trucks that deliver goods and services over large distances. I think there will be self-driving cars that could be urban transport taxi equivalent. There could be a different kind of systems that could be like military grade self-driving tanks, which is again US government is already funding a lot of research to build those. Self-destructive. So basically I think like from an engineer's perspective, I think what makes the most sense is divide these systems, and I think of these systems as like well-defined problem domain and optimize sensors, algorithms for that problem domain.
Not like a holistic one solution to all the problems. त्यो मोडमा चाहिँ प्रब्लम जाँदैन होला भन्नुहोस्.
त्यो मोडमा जानलाई अब फेरि मार्केटको प्रेसर चाहिँ because we are so used to cars, that's sort of how all the consumers think. So I don't know where the industry will end up. But it's in my head like it's almost impossible to have a car that can drive in all possible scenarios, is like consumer friendly enough that even a non-technical person can drive it, and safe enough that I feel okay being on the road with it. Okay.
So in that case, so एउटा like एकदम नचाहिने डिस्कसन हुन्छ नि, like the AI will take over the world भन्ने छ नि होइन. तर यो सिनारियो हेर्दाखेरि त कति पछाडि रहेछ भन्ने फिल भयो नि त. किनकि we humans we can drive in any way होइन, जस्तो बाटोमा पनि जस्तो सिचुएसन we can drive, we can figure it out होइन. तर मेसिन्सले सक्दैन रहेछ नि त होइन. इट्स अ भेरी कम्प्लेक्स थिङ टु डु होइन. सो द एआई इज गोन टेक ओभर द वर्ल्ड एन्ड लाइक ह्युमन्स विल बी रिप्लेस्ड बाई एआई. अनि यहाँ त जति पनि त्यो नचाहिने टपिक्स एन्ड डिस्कसन इट्स अल इनभ्यालिड होइन. दिस अल कन्भर्सेसन मेक्स अल अफ दिस इनभ्यालिड
in a way.
भन्नाले
In a way, I think like there's another risk where our imagination does think that AI is more capable. And in some ways it is, right? Human ko ability hamro ke bhancha advantage is like we make impulsive instinctive decisions really fast and then we can adapt really fast. So ma झ्याप्प ब्रेक हान्ने अथवा हानिन एक्सलेट गरेँ यो मान्छेलाई ओभरटेक गर्छु भनेर, अनि त्यसले झ्याप्प ब्रेक हान्यो भने म झ्याप्प ब्रेक हान्न, मेरो त्यो सोच्नै पर्दैन कि मेरो इन्स्टिङ्क्टले गरिहाल्छ आफ्टर इनफ होइन. And then so adapting to somebody else's decision, making eye contacts and interpreting what the other person is going to do, that's really easy for us. A computer ko case ma tyo hudaina. So there's lots of corner cases where it fails, right? But a computer case ma it can very accurately predict ke yo gadi ma bhanda agadi 10.2356 meter agadi cha मैले यति एक्सलरेट गरे भने यति सेकेन्डमा पुग्छु, राइट? इन अ वेल नोन वेल डिफाइन्ड सिनारियो त्यो एक्युरेसी सेन्सिटिभिटी जुन कम्प्युटरले गर्न सक्छ त्यो हामीले गर्न सक्दैनौँ. 10 मिटर र 20 मिटर उस्तै लाग्छ मान्छेलाई, हैन? अनि त्यो सेन्समा लाइक एन्ड देन when we look at the computer doing these things, which it's really hard for us to do, we think it's way more capable than we are. And so अर्को रिस्क चाहिँ के छ भन्दाखेरि we overestimate the capability of AI. Teslaको autopilot again, very good example. There's so many news articles of people napping, doing other things when we overestimate उसको capability and getting into accidents. So that's one way AI could take over the world, right? We think these decision-making systems are more capable, launch it into as products to non-technical people who don't understand it, and then it gets into bad decisions, which harms everybody.
Yeah.
And so that's in a way like त्यो जुन हाम्रो sci-fi को example छ नि, Terminator destroying humans. In a way it's doing that, but not because it's capable. It's so incapable and we don't know it is incapable. So AI could risk, the possibility that AI can take over the world, can destroy the planet, it still exists. But then it's because that the humans who are making decisions are not completely aware of its capabilities and are not limiting it.
Okay. Interesting perspective on that. So in that case, like जुन अघि तपाईँले भन्नुभयो नि जुन सेल्फ ड्राइभिङ कारै भए पनि or maybe AI based सिस्टमै भए पनि there is always a decision making thing that could go wrong by that is built by them, हैन? तर there is always a narrative saying कि जस्तै for example आजसम्म कार एक्सिडेन्ट्स कति भएको छ, हैन? तर टेस्लाको like we have only seen like or heard of 2 or 3 or 4 of them, हैन? That means like probably use case एकदमै सानो भएर होला, तर like what they say is like AI भयो or like AI based system or like autonomous system भयो भने चाहिँ it will reduce the chances and possibilities of human errors that could come up भन्ने छ, हैन? So what do you feel about that?
I think it's true. I think it's also a lot more complicated than this binary AI versus human. किनभने in a way humans adapt with AI, हैन? So like I'm sure you've dealt with autocorrect and then changed your typing patterns based on based to reduce like autocorrect ko editing ले आफूले edit गर्नुपर्ने chances हरु, हैन? So when we deal with interactive robotic systems, we change our behavior too. So it's not a static thing where human error यति हुन्थ्यो, robotics error यति हुन्थ्यो. It's a system, हैन? And so Tesla को केसमा अथवा self driving car को केसमा yes, human error बाट हुने driving deaths or it's probably going to be much fewer when it's self-driving cars. But at the same time, the other way of thinking about it is like who will be harmed, हैन? Human case ma मैले drive नगरेर accident भयो भने the biggest culprit would be me, हैन? Self-driving को केसमा मैले self-driving car develop गर्दा गरेको error बाट accident हुन्छ, and then whoever gets affected, I am not even connected to that person. And so accountability कसले लिने? Is it the driver? Is it the company who's selling the car? Is it the vendor of the company who's selling the product to the car company, हैन? And so there's layers of accountability and then risks हरु चाहिँ त्यो accountability को boundary मा छ, right? Say I buy the अहिलेको LiDAR scanner मा we buy this LiDAR scanner from this company. Then Ford develops some software. Ford also hires another contractor to develop that software. And then that software ko boundary is probably there's a one corner case that they didn't test, which leads into an accident. It could harm the person who is in the car. It could also hit like a pedestrian. हैन? अनि कसले कसलाई accuse गर्ने, कसको जाम हुन्छ. And so I think the risk with self-driving cars is one, चाहिँ त्यो accountability को के, because checks and balances चाहियो so that everybody is motivated to do the right things. Everybody is incentivized to do the right things, and that is not as well known. A second ठाउँमा problem second scale को हुन्छ. Human driver मा if I'm a bad driver, it's only affecting that one place where I'm driving at any given time.
Yeah.
Right? Drunk driving ka case ma, most of the case, Saturday night, you be careful on Kathmanduko roads. Despite my past. But like if there's a self-driving car which fails, then that's in scale. Every car released by Tesla is problematic right now because we don't know when it fails. Add to it like over-the-air updates, then आजसम्म गाडी ठिक थियो भोलि completely behavior change हुन सक्छ.
And that's affecting our mass.
Yeah, so it's a factor of scale. Globally release गरेको गाडीमा त it's like एउटा mistakeले it can cause distraction like throughout the world. So that's one of the risks, and that's why we should be way more careful, even if like the chances of human errors are much bigger than the chances of machine error.
Okay. Like your perspective बाट मैले सोचेँ नि थिएन हैन. That's very true. Like if like it's एकदम basic example हेऱ्यो भने फेसबुकमा एउटा बग आयो भने that will affect the entire like कति 1 billion users हैन, that will affect the entire user base. तर अब लाइक एकदमै सानो सफ्टवेयरमा लाइक भेरी सानो युजर बेसमा भएको युजर्स छ होइन त्यसले द्याट विल एफेक्ट अ भेरी स्मल सेट अफ द युजर्स होइन. इट्स सिमिलर इन द्याट टर्म्स. सो जस्तै यसको बिगेस्ट एक्जाम्पल कुड बी त्यो बोइङको 737 कि 787 MAX 8 को जुन इस्यु भएको थियो. लाइक एभ्री प्लेन्स इन द इन्टायर वर्ल्ड वर ग्राउन्डेड एट द सेम टाइम बिकज देयर सफ्टवेयर ह्याड अ बग होइन, विच वाज नट वेल टेस्टेड. सो प्लेन्स कार्स भन्दा थोरै नै हुन्छ नम्बर्समा, तर if that happens to cars, like, or maybe any other AI-based system, it could probably affect a very large number of people, and that could be catastrophic. Yeah, interesting. So, यही कुरामा चाहिँ like wanted to talk a little bit about के अरे how like you are also working right now as research fellow at NAAMII, you know. So what do you work on like on a day-to-day basis in that? At like NAAMII as a research fellow?
NAAMII, I don't work on a day-to-day basis. It's more NAAMII is a research institution, and the way they are organized is there's these basically researchers who are affiliated with the organization who have their own research domain. And I've been involved with them for 2 years, and I have my own research domain right now because technically jobless soon. Okay. And I'm doing like independent research. I am working mostly by myself with some collaborations with NAAMII as it happens. Like last year, December dekhi April samma chai I worked on NAAMII specific project about like AI ethics in Nepal. And we looked at like how people, I just saw they get questions, right? How do students, professionals, even like policymakers, but it was really hard to get a hold of policymakers, understand AI. Do they understand AI, and how do they understand limitations and basically responsibility as humans when you're developing AI systems, using AI systems, introducing policies for AI systems.
Okay, so what exactly is AI ethics?
So AI ethics is basically मैले भन्नु पर्दाखेरि चाहिँ again ethics is if you study philosophy, ethics go like multiple semesters go course हुन्छ what is ethics भनेर. So it's difficult to define. So मैले भन्दाखेरि चाहिँ it's a way of formalizing impact of AI. Like we talked about different risks, trade-offs, right, associated with introducing AI systems. How do like we think about it? How do we like even characterize it? So AI ethics is अहिलेको नयाँ field where they do the same things. So you think of AI as like a technical system and then look at it in the context of society, right? What happens when you deploy it? What are the different trade-offs? How does it impact AI developers, AI funders, AI users, and even the people who are impacted by AI users? That I may not use Facebook, but Facebook algorithms does affect me. Yeah.
Okay. So ये ethics की कुरामा चाहिँ there was a documentary that I saw. I think it was from Fox. So उनीहरुकोमा चाहिँ what they tried was it was a very controversial topic at that point. आज पनि छ. जस्तै like if you upload a photo in Twitter, like for example long photo in Twitter, like, and if there is a white person and a black person, like no matter the orientation or whatever happens, like to like if like someone from like having a black color or gray color screen, sorry, not gray, brown color screen, mathi bhaye pani tala bhaye pani, it will always highlight people with like fairer or whiter screen, हैन. So that was a very big like eye-opening thing for me, किनकि यस्तो पनि हुँदो रहेछ है AI मा चाहिँ like systems might get into like biased हुन्छ नि, because त्यसले feed भएको data could be some that could be developed or like could be fed in a place where that's where prevailing, हैन. Just for example, there एकदमै धेरै पहिला there was a app called whatismyage.com or whatever, so if you upload a photo, like it will just say you the age of your person, हैन. I was shown 34 when I was 16 ke. So probably I look like 34 in other countries होला, हैन. So I don't know, हैन. So how do you manage that kind of issues in AI where like you don't your training sets and like whatever the data that you put in is not biased in terms of the geographical regions or like whatever the developers are used to?
You cannot.
Okay.
Twitter ko your example ma actually Twitter ko आफ्नै ethics team, they call it Meta, हैन, did a detailed study of what the biases are. Does the bias exist or is it just fluke? Right? Sometimes maybe like you try 5 samples, audience with the body garदैन अनि it's just like one miscases भनेर. They have a blog post, you should check it out. They looked at it and over time what they realized is like maybe Twitter ko auto cropping algorithm नै unnecessary छ, because depending on why I'm sharing that image, because Twitter is a medium for sharing, right? And maybe I want to focus on certain part of the image and that is why I'm sharing that image, and it may not even like the मान्छेको photo भए पनि what I'm interested in, maybe the books there, like I can take a picture of you right now, share it, and then the purpose of sharing that image is the background ma भएको one of the books to highlight it. Then cropping your face is like useless. But then I could also share the same photo to highlight like how Ravi is so candid during a podcast, right? Then I should crop into your face. And so के photo कतिखेर crop भन्ने कुरा त एकदम use case dependent हुन्छ नि त, and then so maybe automating that is not necessary. Maybe like whoever is sharing the photos should do it. And so मैले भन्दाखेरि पनि त्यही हुन्छ कि what is bias भन्ने कुरा, and I worked like 2 years working on bias detection. Like what is bias भन्ने कुरा नै is you cannot decouple it on where the algorithm is being used. Sometimes the algorithm being biased is good, right? For self-driving cars, an algorithm that will stop whenever it thinks there's a person in front of it, that bias towards पोललाई देखे पनि मान्छे नै डिटेक्ट गरोस्, ट्रास क्यानलाई देखे पनि मान्छे नै डिटेक्ट गरोस्, मान्छेलाई देखे नि मान्छे नै डिटेक्ट गरोस्. आई डु वान्ट टु बिल्ड द्याट बायस, राइट? बिकज एक्सिडेन्टली ट्रास क्यानको अगाडि ब्रेक लगाउनु इज नट एज रिस्की एज एक्सिडेन्टली मान्छेलाई ट्रास क्यान भन्ठानेर हिट गर्नु. सो डिपेन्डिङ अन द युज केस यु मे वान्ट द एल्गोरिदम टु बी बायस्ड. Depending on the use case, you want a perfectly objective algorithm. The other thing is bias, यो जुन race-को bias छ नि, it comes from the data because our world is already like colorist, हैन? We've all felt that. But it also can come from the algorithm itself. There's a very interesting study अहिले भर्खरै भएको, हैन? And then they discovered that even like they generated artificial data, okay, which wasn't biased based on the race, but then they fed it into an AI algorithm, and then the algorithm like the output was still biased. And so maybe sometimes the system itself is biased. And so understanding what the use case is, what the impact of the bias is way more important than trying to remove bias from the algorithm. And then the last thing चाहिँ त्यो bias exist यसरी गर्छ भनेर डेभलपरलाई एकदम राम्रो इन्साइट भयो भने then you can develop like, because त्यो algorithm सिधै रिलिज गर्ने हैन नि त, you make a user interface, you put it into a product, you have like other wrappers around any automated algorithm, right? As a developer we all know that. And then how a person uses that algorithm depends on those things more than like what the algorithm does. So there's other like checks and balances, limits, wrappers that can you put around AI, because AI le ta afai decision liन्छ, it's really hard to tell it what to do. But understanding how the system behaves means that where you release that system, you can develop processes and procedures and user interfaces where you reduce the impact of that bias.
So okay, so the last answer is one-liner is it's not possible.
Yes.
Okay. But it's not possible right now. It's like something that might come up in the future.
I think there's a book called Weapons of Math Destruction written by a mathematician, Cathy O'Neill. And then what she says is like algorithms are opinions embedded in code. Like just the fact that you have an input and then you have a desired output, right? There is some, like there's no objectivity there. Kinani, you want a desired output, right? There's a right and wrong choice. So that means like you're trying to guide the algorithm to work towards certain decisions that you think should be true. And त्यही सेन्समा चाहिँ मैले भन्दाखेरि चाहिँ it's like you can make it race neutral or you can make it gender neutral, right? But you cannot make it completely unbiased from everything because the world cannot be completely unbiased from everything.
Okay, even to be like right, you have to be biased.
Yeah.
Okay.
There is like truth, right? There is like morally right thing, or there is like a desired way the code should work. There is like language case ma, there's diversity, and then one way of pronouncing a certain word is not better than another way of pronouncing the certain word. There's politics embedded in like Nepali भाषाको अहिले यत्रो निस्किरहेको छ हैन, कसको नेपाली चाहिँ शुद्ध नेपाली भनेर पूर्वको पश्चिमको हिमालको पहाडको तराईको सबैको नेपाली फरक छ, अनि यसको नेपाली शुद्ध मान्ने भनेको त बायस हो नि त. सेम थिङ विथ इङ्ग्लिस, राइट? Why is American English more standard than Canadian English or Australian English or British English or Indian English? Those are English and different forms of English. And then by choosing the algorithm, you cannot really tell the algorithm that you can tell the algorithm to do something Indian Magor or American Magor or make it random. But all of them are like valid choices and all of them are biased towards certain representation of English.
Okay, understanding. Interesting. So यही कुरामा like we talked about AI ML, and there is another part that त्यो सँगसँगै अर्को पनि एउटा नयाँ आइरहने टपिक भनेको चाहिँ न्युरल नेटवर्क्स होइन. लाइक what exactly is neural networks?
Neural networks is a way of doing machine learning. अघि हामीले सबसेट भनेको थियौँ नि, just how ML is a subset of AI, neural networks are a subset of ML.
Okay.
They started because I think it started in the 70s. Dates I'm not completely sure, but because scientists thought that was how neurons worked. And then so neural network was a way of like basically trying to replicate human neurons and pretend like this is how the brain works. Now we know better that is not how the brain works, but they are a useful technique in doing machine learning. And the way you do it is like you have a bunch of nodes. Board by
We'll draw in the post production.
You can look at it like neural network garyo bhane circle आउँछ, सबै connected picture आउँछ, anybody can look at it हैन. अनि त्यही हो, it's a network of like inputs and outputs, and then each circle represents a mathematical operation. And so एकदमै high level मा भन्ने हो भने चाहिँ it's a matrix multiplication with some non-linearity embedded in it. एकदम general layman level मा भन्नु पर्दाखेरि चाहिँ that is like one way of thinking how the human brain works. And it's basically a way of like setting the input, doing a bunch of math to get to the desired output.
So like what advantage does it add?
So neural network को each जुन मैले अघि mathematical operation भने नि, त्यो चाहिँ training process मा कम्प्युटरले आफै learn गर्छ के. So you just give it the input and the output, and then the way you design, how you design the connection is kind of how you code like how the input and output are related. And then during training, the जुन matrix multiplication को parameters हरु छ, that's what the computers learned. So whenever you read about like any AI algorithm, right, यसमा billions of parameters छ अथवा हो, त्यो चाहिँ त्यो neural network को डल्लोहरु हो के. And so just the way to make it more complex is just by adding like more nodes. हामीले अरु के पनि गर्नु परेन, त्यो नोड को complexity चाहिँ training process मा आफै build हुन्छ. So it reduces human input of like how to define the problem.
Interesting. So when you were working on all of these AI, ML, and like all related to self-driving, like were you more into developing algorithms, like writing code itself, okay, like or what is the part that you're more involved into?
So I've done many different things. So as an intern, I wrote Excel code. Then for like 6 months at Ford, I worked with a lot of startups evaluating उनीहरूको algorithm. So I wrote code, but mostly evaluation code. And then I went and did experiments. Put that code, like put उनीहरूको system into our gadi, like drove around the city, took inputs, wrote code to evaluate it. Then I did a little bit more of like, again, algorithm development. I did a lot of computer vision related. So 3D object detection, sensor fusion between cameras and lidars and radars, a little bit of cameras and audio. Then last 2 years I was working on what I call uncertainty detection, which started as code development. So writing evaluation code to evaluate the bias, right? So figure out whether my perception of camera computer vision algorithm is biased on the basis of race, gender, maybe like city versus rural areas, etc. And then over time what happened was like you can't really quantify bias. You have to understand applications. So then we had a couple of interns who did the code development, and I spent a lot of time reading about internet use cases, system definition, operating requirements, right? And Oileko made a research in NAAMII and beyond has turned into like that, where I think about the technology, and with my experience, I understand how the AI is developed, but a lot of my work is understanding the environment where that technology was developed and deployed.
Okay. So I just wanted to ask a question related to like, what are the tools and technology that you actually like use to write all of those codes?
So mostly PyTorch and TensorFlow. For initial prototyping, Jupyter notebooks. Sometimes Colab, because I worked at a company and it was confidential, we had our internal systems, right? So lots of Jupyter notebook. For actually deploying the code in the vehicle, because embedded system is Anupersa, so then we would switch to C++. And then TensorFlow has a tool to like convert TensorFlow code into embedded code, so we use a lot of that.
So the reason why I asked this question was I just wanted to highlight a meme अस्ति मैले पढेको थिएँ कि अनि लाइक मैले पनि आफूले पनि फेस गरेको छ कि लाइक पिपल्स whenever they learn how to install pip, they'll just do pip install TensorFlow, like the first thing that they do when like even they don't know the entire system and everything, and they just go into AI and ML stuff. And I have interviewed people who says like they have done projects in AI and ML, but they don't know how to connect a database to a website. So like basics or core concepts or like trying to build a very specific system, or like just trying to replicate an AI project and calling it a day, and like calling yourself as an AI engineer. So ekdamai धेरै देखेको छु कि मैले. Like so what are the thoughts on that, and like if someone really wants to be an AI engineer or like be an ML engineer, like what would be the career path for them and how they can start on that?
So there's different ways of being an AI engineer. I also cannot connect database to a website, full disclosure. There's ML ops, AI ops, which is operationalizing development of AI. Fordma, there was a big team whose job was working with like these big database systems, right? AWS, Hadoop, Fordco internal systems, where they would then build these platforms where I have a data on a hard drive, I connect it, it gets uploaded, and then I can do pip install package and then pull that data. So that requires a lot of information, and it also requires, and then same with AI models, right? मैले develop गरेको algorithm, then they would build systems to upload it to the platform so that I can run tests. Or I can run training process, the week-long, month-long process. I cannot like book my computer to just train and then not do anything for a week. And so ML ops, AI ops गर्ने मान्छेहरू do a lot of that. There's also a lot of nitty-gritty algorithm development where you need to know a lot of math, matrices, right? The neural network कुरा भयो नि, the neural network, how do you connect different nodes? What's the impact, right? You see here about like transformer network or perceptron network or LSTM, RNNs, right? त्यो नेटवर्क आर्किटेक्चरहरू नै डेभलप गर्ने इज भेरी फन्डामेन्टल बेसिक रिसर्च. A lot of people do that, mostly in academia. That's another way of doing it. As an industry ML researcher, what I used to do is a lot of pip insta. But read research papers, look at what networks are coming out, what are their advantages, and then try and learn ways to do that into हाम्रो problem domain, right? Like self-driving car मै कुरा गर्दाखेरि the project I was working on was predicting motorcycle को trajectoriesहरू or गाडीको trajectoriesहरू हैन. And so I have like last 5 seconds को कारको video, I can predict like next 5 seconds को कारको video. अनि the architecture, the algorithms are already there. Data, I have like some new. 60% of my time was spent cleaning data. So MS Excel was sometimes a useful tool. But a lot of it was again Jupyter Notebook, Matplotlib, right? Data science, data engineering गर्ने कुराहरू. And then once I had an algorithm that was working, then I would work with हाम्रो production को engineering teamहरू whose job it was to then take that proof of concept prototype and then clean up bits and pieces, optimize it, right? So that I didn't care about like if I had 4 nested loops which looped 100, like big O of O square O cubed, but then you can't really put that into production. So then we worked with production team to optimize those efficiencies. Then you need like algorithm basic knowledge, right? What's the big O? What's the good way of storing your inputs, etc., etc.
Okay. So what I've understood from entire this conversation is like I was focusing more on the software side of it, like being a software engineer, but you are focusing on the entire domain knowledge of like AI and ML. So it seems like it's not just softwares that actually uses AI and ML to build a feature or something like that on a specific product. There could be a lot of other implementation of AI and ML. Could be embedded system, could be autonomous vehicles, could be XYZ जे पनि हुनसक्छ होला हैन. So if you're trying to enter in like in this field, there are a lot of opportunities around like except software engineering as well.
Yeah.
And at that point, yes, you can be someone who don't know how to connect the website to a database, but being in a software industry, like having the core concept of software might be essential, but when you are working in autonomous vehicles, could be having a core concepts of how autonomous vehicles works and everything works could be essential. So it really depends upon where you're taking a step and like which domain you're entering into.
What you're interested. It takes a village. It also depends on, you do need to know that you need to connect the database to the website and you need to find an expert to do so, right? It's not enough to just do pip install TensorFlow. I think मैले देखेको धेरैजना बिगिनर्सहरूको चाहिँ they do pip install TensorFlow, they run it and they're like, oh, I'm an expert. But they're only expert in that small part, right? Like getting that into a useful product requires other skills. And then you don't have to be expert in everything, but you should know what your limitations are and then find experts who can do that.
Okay, interesting. So do you have any last note to the audience?
I think like मेरो biggest observation in Nepal is it's really exciting. Everybody is really excited about AI, ML, everything. I also think there's a lot of opportunity, but I think people are a little overcome by hype. And being able to cut down the hype is very necessary. It doesn't matter, right? Not all problems need AI-based solutions. Sometimes not having an AI means your solution is simpler, more efficient, more like generalizable. Sometimes having an AI means the same thing. And so knowing where you need AI, knowing where you don't need AI, knowing what the risks and trade-offs are, choosing one version of solution to another is essential. Just because something has an AI doesn't mean it's better than something that doesn't have an AI.
Okay. So thank you very much for joining in this podcast and sharing all of your experiences and expertise. I have learned a lot. मलाई like entire new horizon open up भयो मलाई in this particular field, so thank you very much for that and hope like audiences ले पनि त्यही पाउनु भयो होला.
I'm glad. I love talking about these things, so thank you for the invitation.
Alright, so thank you very much to the audience who will be watching till this end. Thank you very much for tuning in. I'm your host Ravi Mandal, Director of Engineering and CISO at TechKraft. So we'll be back with another guest next time. So until then, have a great time. And if you like our content, please make sure you like, share, and subscribe to our channel. So thank you very much. Have a great time. Bye bye.